time just for the recording. So we are going to start at your y-intercept, which is -4, right here in the equation. I marked it on the y-axis, and my slope is 1/2, which means I rise 1, run 2, rise 1, run 2, and then draw the line. All right, the next one. Start at the y-intercept. So which of these numbers is the y-intercept? Is it the -2 or the 3? The 3, good. And it is a point that is 0, 3, but the most important thing to know is that you're going to be marking 3 on your y-axis. So if you haven't yet, go ahead and mark 3 on your y-axis. And then you're going to make your slope into a fraction. So it doesn't have a denominator, but you can give it a denominator by putting it over 1. And so now we know we're going to go down 2 and right 1. The 2 is negative, but the 1 is positive. So I keep going right. Down 2 and right 1. And then use your ruler to make that line. Raise your hand if you have a question or if you just want to hear that explained one more time. Okay. All right, start at the y-intercept. There's no number there. So what number means nothing? 0, yeah. So I can write +0. Writing +0 hasn't changed the equation at all. But now I can see that 0 is the number I start at, and I can mark 0 on my y-axis. So my y-intercept was 0, 0. Make the slope into a fraction, so I'm going to put it over what number? Always over 1. And so my slope is 4 over 1, which means I rise 4 and I run 1. So I'm going to go up 4 and over 1. And if I try to do it again, I get off the grid, but I can kind of estimate where it's going to be, somewhere about there. And then draw your line. Okay. All right, so now there are two problems that say your turn. So you're going to do the same thing to graph these two. You do not want to use Desmos. You want to be able to do this without Desmos. I'll come around and see if you need any help. All right, so for this one, we're going to start at -6. 0, -6, so I need to find that here. 2, 4, 6, is that right? Yeah. And then my slope is 2 over 3, so that's my rise, and that's my run. So up 2 over 3. Oh, I did not do that right. I went too far. Up 2 over 3. I'm having a hard time counting. Up 2 over 3 is what you should be doing. I think I got it finally. So ignore my extra points there, not those. Questions on D? I'm seeing a lot of good work. All right, in E, I don't have a B, so what number should I add?
0.
Good. Adding 0 doesn't change the equation. Just like dividing by 1 doesn't change the equation. So now I know that I'm going to start at 0, 0, this number. And then my slope is a -2, so does it go up or down?
Down.
Is she right? -2, down, good. Down 2, and then right 1. So even though the 2 is negative, the 1's positive, so we go right 1. Yes?
Can it go up to the left one?
Good. Because that makes a good point. -2 over +1 is the same as 2 over -1. They both equal -2. So Ben's saying you can go backwards as well. That's true. A good sign that you might be doing it right is that your points are actually lining up. Okay? All right. Questions on this page? Something that you'd like me to explain again? Okay, we're going to turn the page. That was review, but the reason we review it is because it's an important concept, and it's possible that you don't remember everything that we did back in like September and October. That's okay. Can I turn the page? All right. Graphing a line in standard form, remember, without Desmos. Okay. We're going to do this with a table of values, but it's a special table of values where you have a 0 for the x and then you have a 0 for the y. Looks like this. We did do this, but it's a little bit less common than the y equals mx plus b. The reason we can't just pull the m and the b from the equation is because it's not written in that format. It doesn't look like y equals mx plus b. This is called standard form. Some number times x plus some number times y equals another number. That's standard form. It's not written in slope-intercept form, so I can't just pull out the slope and the y-intercept. So we're going to substitute 0 for x first. Actually, it says substitute 0 for y first. Find the x-intercept by substituting 0 for y. So I'm writing the equation, but when I get to y, I'm going to put 0 in. So you do that too. I just copy the equation, but instead of y, I put in 0. What is 3 times 0?
0.
I heard 2 votes for 0, so I'll take it. 3 times 0 is 0, so that's just 0. That's nothing. And so I just have 2x equals negative 6. 2 times x equals negative 6. So I need to get rid of the 2 by doing the inverse operation of multiply. What's the inverse operation of multiply? I heard 2 divides. Anybody else agree with that? Yeah. The inverse of multiply is divide. I have all the writing utensils I thought I had. So I'm going to divide both sides by 2. And now the x is by itself, and I get x equals negative 3. And I put that here, because when I put 0 for the y, I got negative 3 for the x. I'm going to pause because it's important to me that everybody has that on their paper. So we're going back to this equation, but this time we're going to put 0 for the x. So I'm going to write 2, and then instead of x, I'm going to put 0. Minus 3y equals negative 6. All right, 3 times 0, what do you get? Nope, 2 times 0, what do you get? Still 0, right? 2 times 0 is still 0. Even though I said the wrong problem at first, the answer was the same, still 0. So be careful now, because this negative belongs to the 3y. We have to bring it down. So that negative comes down. Negative 3y equals negative 6. And then how do you undo negative 3 times y? How do you undo that multiplication? It's still divide. So you still divide to undo multiplication. So we're going to divide by negative 3 on both sides. Negative divided by negative, those negatives cancel. You get positive. 6 divided by 3 is 2. So I get y equals 2. So when I put 0 for x, I got 2 for y. I put that up here. And now I have 2 points to graph. Once you have 2 points to graph, you can graph the line, because it's the only line that goes through those 2 points. So I'm going to graph 0, 2 here, and negative 3, 0 here, and then draw the line between them. So notice we didn't use slope and y-intercept, we used x-intercept and y-intercept. We did not use the slope in this method. So now there's a your turn problem. You're going to do it exactly the same way. I'm going to just start you by making that table. You're going to do x and y. 0 for the x, 0 for the y. And it says to find the x-intercept by substituting 0 for y. So you're going to put 0 for the y, and then you're going to find what the x is. So you're going to go ahead and do that right now. Find the x-intercept by substituting 0 for y. So you want to write the equation down. Instead of y, you're going to put 0. And then 2 times 0 is how much? 2 times 0. It's 0, that's why we cancel it out. So I get 4x equals 16. And then that means 4 times x equals 16. So how do you undo the multiplication? Divide. Now somebody said, do I divide by 4 or do I divide by 16? You divide by the thing you're trying to get rid of. I need to get rid of the 4 so that x will be by itself. So I'm going to divide both sides by 4. That will cancel my 4 out. And now I have x equals 4. So I can put that up here. When I put 0 for the y, I got 4 for the x. That goes there. And now I'm going to do the y-intercept by substituting 0 for x. So I'm going to write this out, but I'm going to put 0 instead of the x. So 4 times 0 plus 2y equals 16. I wrote it all out, and I put 0 for the x. 4 times 0 is still 0, and so I get 2y equals 16. And what did you get when you divided both sides by 2? Anybody else get 8? Okay, good. So y equals 8, and you can put that up here too. Excellent work. All right, so now we're going to graph these points. If you haven't graphed them yet, we're going to graph them now. If you did graph them, just check and make sure you got them in the right place. Remember, this is my x-axis. It says x, but it's really small. And this is my y-axis. So I'm going to graph 0, 8 on the y-axis. And I'm going to graph 4, 0 on the x-axis. And then I'm going to draw the line between the graphs, or between the points. All right, who has a question on that one? All right, really good focus today, guys. Okay, the reason we graph lines is because the solutions to the equation are on the line. And an equation has lots of solutions. Not every number or pair of numbers is a solution, but it has a lot of them. Because if you think about a line is made up of an infinite number of points. Between any 2 points on the line, there's another point. So there's really an infinite number of points on the line, and every point on the line represents a solution. You can check if a point represents a solution by substituting the numbers into the equation to see if the result is true. So here's the equation that we're checking. Y equals, oh, here it is. Y equals 2x plus 5. In the point, what comes first, x or y? X. It is. If you forget, if you get confused, it's alphabetical order. So x comes first and then y. So this is x and this is y. 3 is the x and 10 is the y. So if I'm going to substitute into this equation, I'm writing the equation out again just to be clear what I'm doing. That's the equation. I'm going to put 10 for the y and I'm going to put 3 for the x. So I get 10 equals 6 plus 5, which leads to 10 equals 11. Is this true? Does 10 equal 11? No. What kind of math would that be, right? 10 does not equal 11. They're different numbers. So that tells me that this is not a solution. It's not a solution to the equation. Not a solution. So you can check if a point is a solution by substituting it in to see if it's true. Okay? You guys are packing up, but we still have 3 quality minutes of work time here for us. So, I want you guys to try this one. Same equation, still y equals 2x plus 5. What number are you going to put for the y? Is it the -1 or the 3 that goes for the y? It is the 3. So put 3 for the y, put -1 for the x. See if it's true. If it's true, then it's a solution. If it's not true, then it's not a solution. Go ahead and try it. Alrighty, so this is the one you guys were working on before we left, right? Aisha, you ready? This is the one we were working on before you left. So we put 3 for the y, 2, and then we put -1 for the x, and then plus 5. So I got 3 equals -2 plus 5, and 3 equals 3. So is that true? 3 equals 3? Yeah. So when you get 3 equals 3, that means this one is a solution. Okay? If you haven't done the third one, I need you to do the third one right now. So we're still using y equals 2x plus 5. And we're going to put in the 17 for the y and the 6 for the x to see if it's true. Okay? Remember, this is your x, this is your y. Go ahead and get that one done. I'll come and check in with you and see if you need any help. All right, so we put 17 for the y, and then we put 6 for the x. I get 17 equals 12 plus 5, and 17 equals 17, which is true, right? 17 equals 17. All right, so what that means in the end is that this point is a solution. All right, my answer is not 17 equals 17. That doesn't make sense as an answer. Of course 17 equals 17, right? My answer is that this point is a solution to the equation. All right, so Ronnie brought up a really good point. He said, since the solutions are on the line, can't we just look at the line? So if I give you the line, you can do that, and it is a little bit of a shortcut. It's nice because the line represents all the solutions. So if a point is a solution, it's on the line. So if we want to use the graph, this is the graph of -2x plus 3. See how it starts at 2, and it has a slope of down 2 and over 1, right? So that was your slope, that was your point, and now we're going to check and see if these points are solutions. Let's take a look. First one is 2, -1. Let's find 2, -1. Is it on the line? Guys, I just graphed a point. I just asked you if it's on the line. Yes, it is. So 2, -1 is on the line, so it is a solution. Graph the other points and tell me if they are a solution or not a solution. 3, -2, was it a solution? Raise your hand if 3, -2 is a solution. Raise your hand if 3, -2 is not a solution. I have answers from about half of you. Thank you if you've answered. 3, -2, I'm going to check it. +3, -2. Oh, it's close, right? But not exactly. 3, -2 is down here. So this one was not a solution. All right, next one, 1, 4. All right, 1, 4. Raise your hand if it is a solution. Raise your hand if it is not a solution. Okay, thanks for participating. Let's see if I get the same thing. 1, 4. It's way up here. You are right. Definitely not a solution. Okay. Who has a question? Okay, let's turn the page. All right. We're going to talk about linear inequalities. Inequality means not equal, greater than or less than. And when you graph an inequality, you're not just graphing a line, but you're going to be shading it, because basically half of the points are going to be solutions and the other half are not solutions. So every point in the shaded region is a solution. We're going to graph y is less than or equal, you can't even see that, y is less than or equal to 1/2 x minus 3. So we start by pretending it's a line and graphing that. So if I was going to graph y equals 1/2 x minus 3, I would start at what number? I heard 2 votes for -3. You are right. So graph -3 on your y-axis. All right, from -3, we're going to use our slope. What number is our slope? It is 1/2, right. So our slope is 1/2, so we're going to go up 1 and over 2. And then use your ruler to draw the line. All right, now we want to shade the area that is less than the line, because this symbol means less than or equal to. The equal to is the line, the less than is below the line. Okay, so less than is below. Does anybody get these symbols confused? All these symbols, does anybody get them confused? I do. I get them confused. Everybody has a different thing that their elementary school teacher taught them to keep them straight. For me, it was that the less than, it looks like an L, right? Here's my less than symbol, and it looks like a tilted L. If you write it backwards, like this way, that one does not look like an L. This one kind of looks like an L. This one, not so much. Does anybody have a different way they remember which one's less than? No? All right, well, if you have one, be sure to share with your neighbors. But for me, I just like to remember that the less than, it looks like an L. So it says every point in the shaded region is a solution. So like, let's look at our graph here. Is 5, -5 a solution? 5, -5, is that a solution? Why not? Is it in the shaded region? Yeah, so every point in the shaded region is a solution. Is 1, 2 a solution? No, right, because it is up here. It's not a solution. Okay, it's your turn. It's right here. Start by graphing this line, and then you're going to shade the area that is greater than the line. Okay? You guys are doing this. All right, I'm going to start at -1. I'm going to graph that point. And then my slope was not a fraction, so I'm going to make it a fraction by putting it over 1. So from -1, I go down to and right 1. Please check that. A lot of you are still having a little trouble with the slope, and that's okay because you're learning, but you need to make sure you make corrections, okay? So as you go through, make sure that you have the right slope. I can tell this is a negative slope because when I read it from the left to the right, I'm going down. So I know I got my slope right because it's negative right here. All right, this time it says shade the area greater than the line because this means greater than or equal to. Sometimes when the line is like diagonal, it's hard to know what part is above the line. So you just put your marker or your pencil on the line and go up. That's the part, okay? So greater than is going to be above, like that. Before we start doing C, we're going to read the whole thing because in C, there's something that's a little different. I'm going to wait because I can see some people fixing their graph, which is good. Thank you for keeping up and for making corrections as you go. Okay. This time we're graphing y is greater than 2/3 x plus 4. It says start by graphing the line, but the y doesn't equal 2/3 x plus 4 because there's no equal sign on it. Do you see how it's different? It just has a greater sign on it. So it's only greater than the values on this line, and you show that using a dashed line. So a dashed line is like a wall, but it doesn't include the line, okay? So this time when we graph, we need to do a dashed line like this. Everything else about graphing the line is the same. Where are we going to start our line? At what number? Thank you, yeah. We're going to start our line at 4 on the y-axis. Go ahead and graph 4 on the y-axis. Right here. My slope is 2/3, so I'm going to go up 2 and right 3 like that. And do you guys remember what Ben told us at the beginning of class? You can go backwards and go the other way. So I can go down 2 and back 3 so that I can get some more points like that. So those points all have a slope of 2/3. Up 2 over 3, up 2 over 3, up 2 over 3. But I'm not going to make a solid line this time. I'm going to make what kind of line? Do you remember? It's right here in all caps. You're making a dashed line. So when you make your line, make sure you make a dashed line. Sometimes I forget and I mess up, and then I just draw a dashed line on top of the solid line if I forget. Like that. Raise your hand if you can tell me why I made a dashed line there. Raise your hand if you can tell me why it's a dashed line. I see 1 hand, 2 hands. I want to see more. 3 hands, good. 4 hands, very good. Angel, why is it a dashed line? Okay, so he said if you're looking at the greater than or equal to sign, this one doesn't have that dash under it, which is the equal part, right? So it's not equal to that line. Very good. So that means the line is not part of the solution. Shade the area greater than the line. So greater, would that be above or below? Still above. Good. So from your line, you're going up. Okay, so now, this time the points on the line are not solutions because it's not equal to that line, but the points that are shaded above, those are solutions. All right, it's your turn to graph D. In D, there's no number in front of x. X is the same as how many x? Say it out loud, Anna. 1. Yeah, x is the same as 1x. So your slope you'll be using is 1 over 1. Okay? I need to see you guys doing D. Here we go. Did you start at -2? And then did you do a slope that was up 1 and over 1, up 1 and over 1 like this? Is that what you did? Did you make a solid or a dashed line? Dashed, very good. It was dashed because it doesn't have an equal sign on it. And which way do we shade? Below, because this is less than. Less than. Shade below. Good. All right, we just have a half page left. I'm going to leave this up for about 20 more seconds. If anyone needs to write it, then we're going to turn the page, okay? All right, here we go. All right. So there is a good point made that we do have to do a project. So what we're going to do is we're just going to check these two here. But these we can check all of them because that's really an easy process. We're going to check if these 2 points are solutions to y is greater than 2x plus 3. So do I put -1 for x or y? For x, thanks. And this is going to go for y. So I'm going to write y is greater than 2x plus 3. And I'm going to substitute the 2 in. And now I'm going to figure out if it's true. Okay, 2 times -1 is -2. -2 plus 3 is 1. So I get 2 is greater than 1. What do you guys think? True or not true? 2 is greater than 1. That sounds true. Yeah. And that means that this point is a solution. We're going to check B. What number should I put for Y? 3, good. 3 is greater than 2 times 0 plus 3. 2 times 0 is 0. And I get 3 is greater than 3. Is that true? Is 3 bigger than 3? No, 3 is not bigger than 3. They're equal. So because 3 is not greater than 3, this is not true. And this is not a solution. To check graphically is a lot easier. When you have a graph, it shows you all the points that are solutions. The points that are solutions are in the shaded area. So let's check one together. 1, 3. Is 1, 3 a solution? Yeah, because it's in the shaded area. All right, check the other ones. And then after that, we're going to be working on makeup work, okay? Check B, C, and D. All right, B, raise your hand if 6, 1 is a solution. Raise your hand if you said it is a solution. Okay, raise your hand if you said it's not a solution. Let's check. 6, 1, very good. In the shaded area, yes, it's a solution. C, 4, 6, raise your hand if yes, it's a solution. Raise your hand if no, it's not a solution. Let's check. 4, 6, you're right, it's out there, it's not a solution. D, raise your hand if it is a solution. Raise your hand if it's not a solution. Let's see. 3, 5. It's on the line. Are points on the line a solution? If it's a solid line, yes. If it's a dashed line, no. Okay? So because it's on a solid line, yes, it's a solution.